Today we are covering section 9.1, looking at translations and vectors. We've talked about translations before, but we're going to look a little bit more in depth and really get into doing some actual translations. So a translation, if you remember from before, is just a shift of all the points, the same distance and direction. So all the points move the same distance and the same direction. The new figure that we get is called the image, so the ending points are called the image. Our original figure is called the pre-image, so pre meaning before. So be careful when you're reading problems to see whether they're giving you the pre-image, what you start with, and then do the transformation, or are they giving you the image and asking you to work backwards to find the pre-image. Most of the time you'll start with the pre-image and work to the image, but they do like to change that up every now and then. When we're marking our points, usually we add an apostrophe at the end, which is read as a prime. So P becomes point P prime. As you can see down in the example below, we have A and then A prime, B and then B prime. Most of the time you'll notice translations given in coordinate notation, which means they'll give you an equation and they'll tell you that your X is going to add 3 and then your Y's are all going to subtract 1. So this is called coordinate notation, and you can just do literally what it's telling you to do to get your new points. And a translation is an isometry, which means all the lengths and angle measures stay the same. It doesn't get bigger, doesn't get smaller, doesn't get distorted in any way. It just moves where it's at. Another way that we can write these translations is through vectors. Vectors have a starting point, an initial point, and an ending point, so it doesn't go on forever like a ray. This arrow just tells us the direction that it's moving, where our starting point is and where our ending point is. So that can represent a translation as well. Vectors have component forms. Component forms just tell us how far left or right we're moving, how far up or down we're moving. So it's always our X first and our Y, just like our points. So in this case, to go from B to C, because the arrow is going that direction, we would move to the right 9 and then down 2. So its component form will be 9, negative 2. In this one, be careful, is starting at S and going to T. So we're going to the left 8. So we subtract 8, negative 8. And then we're not moving up or down. So its vertical component is 0. Let's look at a few examples and get you started. So in your first section of IXL, they're going to have you just do your translations and then write the coordinates out for your points. Pretty straightforward. Just make sure you're looking at what's left and right, what's up and down. Left and right affects your X, up and down affects your Y. So since we're going 2 to the left, you could go straight to your points down at the bottom and just subtract 2 from all the X's since we're going to the left, or you can physically go on the graph and move to the left 2, and then 6 units up and note your point from there. So like I said, you can do it from the graph or from the coordinates, doesn't matter. So in this case, if we're going to the left 2, my first point T prime would be negative 6. And then if I'm going up 6, that would become 7. U prime, I'm going to the left 2, subtract 2, which would give me 2. And then up 6 would also put me at 7. V prime subtracting 2 would be 2. And then up 6 would be at 10. W prime subtracting 2 would give me negative 6. Up 6 would give me 10. Hopefully this section goes pretty fast for you. Once again, just make sure you pay attention to what's left and what's right. That'll tell you whether you're adding and subtracting into which part. Second section of IXL is really just working the other way around. They're just asking you to write the rule now. So you want to look and make sure that you're going from the pre-image to the image, so the one without the apostrophe to the one with the apostrophe or prime. So in this case, to go from R to R prime, I would have to go from -5 on the x to the right 7 spaces to get to 2. So I would have x plus 7. And then my y's, if I'm down at -9, to get to this r, I'd have to go up 11 spaces. So that would be y plus 11. Be careful, sometimes they have the x part already written for you, so you just have to write in the 7 and the 11. Sometimes they will not have that, so you have to actually type in x plus 7, y plus 11. If you go to the left, the x will be minus. If you go down, the y would also be minus. Once again, be careful to go from the pre-image to the image, not always left to right. Last section is just going to ask you to write the vector in component form. So you just want to start with your initial point, the one without the arrow, going to the one with the arrow, and describe your left and right, up and down movements. So always starting with the x. So if this x is at 0, I'd have to go to the right 2. And then in this case, then I would have to go down 5, so it'd be -5. They won't always start at 0, so just make sure you're counting the number of spots from the starting point to the terminal point. Hope that helps. As always, ask questions either through email or Flipgrid, and let me know what you need.